Hello, this is going to be a classic Becky and Dr. P video because my cat Becky is right here, conveniently in the way. And I wanted to introduce how to use the Excel solver to solve linear programs. So this is coming from a linear programming angle. So it's organized according to generic linear programs. So you're in an introductory optimization course. So let's talk about it. So Solver is an add-in to Excel. You want to have it available. You can find it in the data tab. If you have it, you'll find it here. I'm on a Mac. It's similar for PC. If you don't have it, then you need to activate it. You can do that by going in Mac under Tools to Add-ins. And here you need to make sure it's checked, or if it's not there, you need to go add it. Similar process for PC, except it's under File Options Add-ins. So once you have it available and you can see the button here, you're not going to start by pressing it. You're going to actually use a setup like this. Here I have my decision variables. Here I have my constraints. Here I have my objective. What you'll notice what's weird about Excel is, so in Math World, we write an LP all in terms of variables x1 and x2. So we write ax less than or equal to b, and the objective is cx, right? However, Excel does not allow you to write your objectives in terms of variables like that. So that means you have to actually give it values, which is, we generally don't assume that we know the values of the decision variables, but in Excel for Solver, you have to. So you can assign each of your decision variables a feasible value. So if you have non-negative variables, you can just set them all equal to 0 like this. And that's our starting point. So from the setup, you want to make sure you update the parameters for constraints and objectives. So here I've highlighted all the parameters in blue. This is just some simple made up problem. So depending on your problem, update these values to be appropriate to your problem. Right now they're written in all less than or equal to form. You can change it and Solver can adapt to that, but it's easiest in this form. All right, so the next step is to enter or update the equation column in D. So here's when you start to combine the parameters with the decision variables in a very Excel way. So I'm going to write an equation where I multiply parameter times variable plus the other parameter times its variable. And now that's the value 6 times x1 plus 9 times x2. And if you're familiar with Excel, then you know we can go in and make these references static. So everything in the 10th row, I want to be stationary like this. So adding $signs there. And now that allows me to simply copy paste this whole equation. You can see that this row of variable references is dynamic. It's moved down a row, but this variable, these references have been static. They won't move, which is perfect because now I can just copy paste for all of these rows. And so it's important to check that you've done this correctly. And one easy way to do this is to just go enter something besides 0 here. So I'm going to do 1 and 1. That's my feasible solution. And you can see that that is now updated these values here. So 6 plus 9 is equal to 15. So we're good. You can check all of your constraints like that and check your objective. Everything looks clean now. Cool. So go back to 0, 0. Not that that really matters. But now we actually jump into the Solver tool. So I'll open Solver. It's this little window here. And because we've set up our problem like this, it's actually very easy to fill in this stuff in. So set objective, click that button. Now I get to choose the box I want. So this objective value is what I want. You can choose max or min. By changing variable cells, so this cell is asking me to point to the decision variables. So I've highlighted these two here. And then subject to constraints. So let me delete those and add. So here you can actually add multiple at a time. So on the left-hand side of the inequality, I want these. They are all less than or equal to constraints, but here's where you could modify that. The right-hand side of the constraint is this column here. And then, okay. So that has now added the constraints here. So I have my objective, decision variables, constraints. This is the non-negativity assumption on essentially all variables, which is what we want. For this problem, we want that. So keep that. And then I made a note here. We want to make sure the solving method for an introductory course is the simplex LP. Oh, it's being weird. So there's a nonlinear option, there's an LP option, and there's an evolutionary option. So we want the simplex LP. Solve. So you can see that it has automatically updated these decision variables to what it has found to be. It says solver found a solution, and it shows you the solution. I don't think I don't know how Excel handles unbounded problems or infeasible problems. I don't know if it would even tell you the difference. So Excel is good for solving small problems where you know a optimal solution exists. So it tells you that this is asking if you want to keep the suggested solution or revert back to what I had before. Also, there's the option for giving reports. I suggest just getting them all. You can look at them later and then click OK. So it's now kept that solution and it spit out 3 different reports. So I just want to talk about those. So the answer report talks about the solution. So original value, final value, and the final objective value, final decision variable values. And then this talks about the constraints, essentially whether or not they're tight or active or binding, whatever you want to call them. Sensitivity report is a bit more advanced, but it's interesting to look at. The limits report, I don't think is that interesting. Cool. So thank you for watching. I hope this is helpful. And Becky and I are signing out.